Alright, so in this video, we're going to learn how to evaluate this expression without a calculator. Sine of 240 degrees. Let's write that here. So sine of 240 degrees, right? And we want to evaluate this, right? So what we can do is first we can take 240 degrees, and what do we know best? 360 degrees, right? That's one full rotation. So, how do we get from 360 degrees to 240 degrees? We can subtract 120 degrees from it. So, from this, we can rewrite sine of 240 degrees as sine of 360 degrees minus 120 degrees, right? It's still going to give us 240. I mean, not 0, but yeah. So it's going to give us 240 still, right? But a common misconception is this is going to be equal to sine of 360 degrees minus sine of 120 degrees. And this is wrong, because that's not how trigonometric functions work. You can't, like, it's not like multiplicative distributive property, right? With like regular constants and whatnot. So it doesn't work like that. We have to follow a specific formula. So the formula is going to be, I should probably, okay, about minus. The formula is going to be sine of A minus B, which are these two values, 360 is A and 120 is B, equals sine of A, I don't need the parentheses, okay, sine of A times cosine of B minus cosine of A times sine of B, right? So using this formula, we can map all the values, and then express this function, this equation, as this. So we know that 360 is A and 120 is B. So sine of A, which is 360, times cosine of B, which is 120 degrees, minus cosine of A, which is just 360, so cosine of 360 degrees, times sine of B, which is going to be, B is going to be 120, so 120 degrees, right? So from here, we can simplify this further. So as you can see, we can simplify sine of 360 degrees into 1. Well, how do I know that? Well, you can look at it like this. So on the graph, the point 0, 1 is going to be around there, right? 0, 1. And however many times you rotate this, like the amount of degrees, let's say rotate it 90 degrees counterclockwise. 90 degrees counterclockwise would be like over here. That's gonna be 0, oh wait, that's 1, 0. My bad. That's 1, 0. And if you rotate it here, it's gonna be by 90 degrees. It's gonna become 0, 1. So basically, this is rotated 90 degrees, right? So from here, you can notice it's just a given fact that if you apply cosine of 90 degrees, you will get the x value of the image of the rotation. So the image of the rotation is 0, 1. The pre-image is 1, 0. Cosine of this angle of rotation is going to bring you the x value of the image. So it's going to be equal to 0. And sine of 90 degrees is going to bring you the y value of the image. So that's going to be 1. So from here, we can find out what 360 is. So if we rotate, if we rotate this 10 point by 360, it's going to map on that exact location. So, in other words, rotation of the point 1 comma 0 by 360 degrees, counterclockwise or clockwise, doesn't matter, around the origin is going to result in the same point. Right? Agreed? So now, we know that the cosine of the degree, I forgot the degrees, okay. So the cosine of the angle of rotation, which is 360, is going to be equal to the x value of the image, which is going to be 1. And sine of the angle of rotation, which is 360 degrees, equals the y value of the rotation, of the pre-image, of the image, right? So it's going to be 0. So now we have this and this. What do we see in our equation? We have sine of 360 degrees. What is that? That's 0. And whatever you multiply by 0 is just going to become 0. So we don't even need to evaluate this. So this is just 0. And then minus the cosine of 360 degrees. We see that it's 1. So minus 1 times that is just going to be sine of 120. Sine of 120 degrees. This has been all clumps, so I'm just going to write it down here. 0 minus sine of 120 degrees. So now, this is going to be negative sine of 120 degrees, which is going to be negative 1 times sine of 120 degrees. With this 120 degrees can also be written as sine of 60 degrees plus 60 degrees. Right? And if you look at the unit circle here, if we plot a graph right here, just like that, a unit circle is going to look like that, where the radius is 1 and it's centered at the origin. And if we draw a line, from here to here, and then draw like a perpendicular line to the x-axis, it's going to create a right angle, right? And we call this the hypotenuse. We created a triangle, right? A right triangle. So this is going to be the hypotenuse, and we know that the radius is 1, and this is a radius of the circle. So we can call this side 1. And since, let's just say that this side length is going to be x, and this side length is called y. Let's just assign like that length to it, right? And so this coordinate point right here is going to have the coordinates of x comma y, right? So to actually solve this, right, what we can do is we can call this angle theta, right? Or x, or whatever, right? But actually I already claimed, so we just call it theta. Theta looks like that. It's a Greek letter we use to assign angles, right? So if we take the sine of theta, that's going to be opposite divided by hypotenuse. So, katoa, right? So is going to be opposite divided by hypotenuse. So sine of theta is going to be the opposite, which is y, over the hypotenuse, which is 1. And what is something divided by 1? That's something, which is y. So sine of theta is equal to y. So basically, we can replace this y to sine of theta, right? Because they're both equal to each other, right? And likewise, if we take the cosine of theta, that's going to be adjacent divided by hypotenuse. So toa. So AH, that's going to be adjacent over hypotenuse. So the adjacent side to angle theta It's going to be x, and the hypotenuse is obviously 1. So cosine of theta equals x over 1, which is just equal to x. So cosine of theta is equal to x. So that basically means we can replace x into cosine of theta. So because we have these two values that both map to x, y, we can get the coordinate point as cosine of theta, comma, sine of theta. Right? So now I'm going to tie all this in, right? So the x coordinate is cosine of theta, and the y coordinate is sine of theta. This is basically why we got, like, why the x coordinate is going to be like the cosine, and then the y coordinate is going to be the sine, right? That's basically the why, okay? And so how we're going to tie this in is basically, we need the sine of 60 degrees, right? So what we can do is we can just make a triangle, suppose this triangle, this right triangle. Oh my gosh, that's a bad straight line. Let's suppose that this triangle is a right triangle. It's a 60 degrees, 30 degrees, and 90 degrees triangle. So this has special properties. Let's call this short leg, a short side, x. The side length opposite of the 30-degree angle, right? The hypotenuse is always going to be 2x, no matter what. And the longer side is going to be the opposite side of angle 60 degrees. So it's going to be x root 3. This is going to be true for everything. So let's say this triangle is in the unit circle. Let's say that. Let's see. Let's say that it's part of the unit circle, right? So we know that this is going to be equal to 1, but it's also 2x. So that means 2x is equal to 1. We can solve for x right now. So divide by 2 both sides. We get x equals 1/2. And if x equals 1/2, then this must be equal to x. So x is 1/2. And x root 3 is just root 3 over 2. Right? So now we have literally all the side lengths we need to find sine of 60 degrees. Sine of 60 degrees equals, we look at the 60-degree angle here. It's going to be opposite divided by hypotenuse. Opposite divided by hypotenuse. Opposite is going to be root 3 over 2. And the hypotenuse is just 1. Anything divided by 1 is just that thing. So it's just going to be root 3 over 2. Over 2. So sine of 60 degrees equals root 3 over 2. So you might be wondering, how does this tie in? Well, we can say that this is -1 times sine of, and we have to actually use a different formula for this. We have to use the sine of a plus b formula instead of a minus b, and it goes somewhat like this. Sine of a plus b equals sine of a times cosine of b. The difference here is that you're adding these together, not minusing, not subtracting. That's the only difference. Sine a times cosine b plus cosine a times sine b. So if we plug this in, a is 60, b is 60, sine of 60 degrees times cosine of 60 degrees plus cosine of 60 degrees times sine of 60 degrees. Right? All times -1, by the way. Keeping that -1 there. So now we know, we already know that sine of 60 degrees is root 3 over 2, right? Now let's find cosine of 60, because that's all we need to solve the equation, right? If you look back here, we can see that if we find cosine of 60, That's going to be adjacent over hypotenuse, right? SOHCAHTOA. Adjacent is 1/2 divided by the hypotenuse, which is just 1. So it's just 1/2, right? So sine of 60 degrees, which is root 3 over 2, times cosine of 60 degrees, which is just 1/2. So times 1/2 plus cosine of 60 degrees, we already know that's 1/2, times sine of 60 degrees, which is just root 3 over 2. So now we can solve this. So that's going to be root 3 over 4 plus root 3 over 4. That's going to be -1 times 2 root 3 over 4. -1 times root 3 over 2, which is going to bring us -root 3 over 2. So that's how you're going to find sine of 240 degrees.